Alright guys, so the last place that we stopped was the isotope question. So the question was, copper has two main isotopes, copper 63 and copper 65. Given copper's average atomic mass of 63.546 AMU, what is the abundance of each isotope? I've got the lecture slides in front of me rather than behind me, so my apologies, but this is how it's going to work. So, copper 63, copper 65. My weighted average is 63.546 AMU. I remember that my original equation was 63.546 is equal to my 63 AMU isotope times some abundance X plus my 65 AMU times some abundance Y. I also remember that my abundance X plus my abundance Y must add up to 1. So the way that I can solve for this is, given two equations, I can solve for X or Y. I'll choose to solve for Y, which is 1 minus X. I can take that and move it right down and replace Y with that so that my one big equation has only one unknown. So 63.546 is equal to 63X plus 65 times 1 minus X. Keeping going with this, 63.546 is equal to 63X plus 65 minus 65X. Now if I calculate this out, I should get here 65 from there minus 2x. Again, 63x and negative 65x, I get negative 2x, and that is all equal to 63.546. I subtract 65 from both sides, and I end up with negative, let's get my calculator, my phone calculator. Got my handy dandy phone calculator, doing 63.546 minus 65, and I get negative 1.454 is equal to negative 2x. I divide both sides by negative 2, divide by negative 2, I end up with x is equal to 0.727. That would be the abundance of my 63 isotope. So, 63 isotope in decimal form was 72.727, so my percentage would be 72.7%. And if I know my abundance of X, I can instantly find my abundance of Y. Again, 1 is equal to X, which I know is 0.727 plus Y. So, 1 minus 0.727 gives me my abundance of Y, which is 0.273 in decimal form, or 27.3% in percentage form. So that was the end of that problem. Now, the next one that we are going to work on is the nuclear symbol. If you look, we're going right along with my lecture slide. The next slide is the nuclear symbol. So when I have a nuclear symbol, you've already seen that the way that I write the mass is up top. So this number up top, I'm calling it A, I believe, and that is my mass of a specific isotope. Again, that mass, the way that I write my nuclear symbol is for one atom, one single isotope. So it is not going to be the average mass that's found on the periodic table. It's going to be the mass of this particular isotope. Now, the next number is a little redundant, but we write it anyways. We say that the bottom number is Z, or my atomic number. My atomic number, again, is the number of protons. So the number of protons, sorry, that plus looks kind of funny. Number of protons is my bottom number. So if we go back to chlorine, that slide about chlorine, the way that I can write my isotope is either chlorine, always 17, chlorine, always 17. My top number being, for the first one, 35 AMU for my mass. My top number for the second isotope would be 37, my mass of the second isotope. So hopefully you guys are able to do the practice problems here. Practice problems in that table. Remember that protons contribute +1 charge as well as 1 AMU of mass. So if I'm looking at my mass here, my mass column, the only things that give mass are protons and neutrons. If I'm looking at my charge column, the only two things that contribute charge are protons, positive charge, and electrons, negative charge. My symbol, again, is just my element symbol. The top number is the mass, the bottom number is the number of protons. So what I expect then for Monday is that you guys have this completed. That will be another little mini worksheet grade, and you will work on the worksheet this weekend. So if you are watching this video and you have heard directions, that means that worksheet 2 is due on Monday. Worksheet 2 is due on Monday, meaning you must have worksheet 2 completed by Monday. Worksheet 2 should be completed by Monday, as well as this little practice problem. So what we can do is work on that practice problem as well. I'll put that in the next video.